I'm going to record it, and let's share my document camera here. Okay. Can you see the screen?
Yes, I can see it.
So it is quiz 5 now, right?
Yes.
Quiz 5. So this Friday, quiz number 5. Okay. So it will be about the transformation technique. Transformation technique. Okay. So it is about transformation technique. So what we are going to do, there is different density function of random variable transfer random variable equals to f y f inverse u and derivative of d f inverse u. Okay, so quiz 5 will be about this one. Okay, so this Friday
Okay.
we start class now. Okay, so it will be in person. Okay, in class. Huh? Yeah, transformation. We are going to cover the, we started yesterday, we started on Monday, right, this technique. So we are going to cover today, and so you will do the SYNGAC assignment same as we are covering today. Okay, so do that assignment also, so that it will help to understand. And let's start now. Okay, now we start the transformation technique, right? Transformation. Transformation technique. So in transformation technique, last time we did for the random variable u h y increasing case, right? Increasing case. That's what we did, right? And we got that density function of transform variable u f u equals to h y h inverse u and d h inverse u, right? That's what we did last time. We did an example, right? We did an example. So it is here, this one. So we did this one here last time, right? When it is an increasing function. And we did this example here. Right? Example 6.6. Now let's do whenever the case u equals to hy decreasing case. Yes, okay. Now we want to do for the decreasing case. Okay. Now when it is the decreasing case. Now when it is a decreasing case, it means that we have the graph like the decreasing function, right? And we have the y here, and we have the u here, and this is equals to u equals to y. Okay. U equals to y. So it is a decreasing here. Now whenever you have the y here, then you will have the u, this is equals to y, right? Now, for the decreasing case, now we have u equals to hy, right? U equals to hy, and we want to find the probability density function for random variable u, right? So that is equals to f u u. So this is equals to f y f inverse u and d f inverse u. Okay, now we want to prove this one. Prove this one. Okay, we want to prove this one. Okay, Amanda. Okay, now here we have using the definition of cumulative distribution function, right? So it is f u and random variable u, right? Random variable u. This is equals to probability applying the definition. Okay, so this is equals to what? Random variable u is less than or equals to u, right? That is the definition. Now u equals to probability h y, right? This is h y here, less than or equals to, right? Now you see here, this is a decreasing function, right? This is a decreasing function. So whenever you take the inverse, so u is less than u is this part here, right? Here. So whenever you take this one, the inverse function, probability y is greater than, you see, it comes to this part here, greater than h inverse u. Okay? Because it is a decreasing function. Yeah, because it is decreasing, you have to take now this part here, right? Now, we want to convert this to the cumulative distribution function. So total probability equals to 1, we take the complement, right? So this is equals to 1 minus probability y is less than or equals to h inverse u, right? H inverse. Now here random variable is y here, right? Yes, random variable is y. Now apply the definition of cumulative distribution function. So this is equals to 1 minus f, input value is h inverse u, right? Now random variable is y here, right? Yes. Now this is f u u. Density function of transformed random variable u has a density function equal to this one, right? Now we want to find the density function. What we do density function to find the density function? Take a what? From CDF to PDF, what we do? Huh? No. Derivative, right? So you would like to find the derivative. Take derivative, right? So f, u, and u. Now this is density function, right? Yes, density function. So this is equals to d by du. Take a derivative of the cumulative distribution function, right? Yes. So this is equals to d by du. So plug in this value here, 1 minus f y h inverse u. Right? Yes. Now, derivative of 1 is what? 0 minus derivative of this function, right? F, y, F inverse. Now, Amanda, it's now you have to apply what? Take a derivative, right? Take a derivative, right? So you have to take this. This is the CDF, right? So if you take the CDF derivative, it will be CDF, right? Now, but this part is not a U. It is U here, but this is not U. So you have to apply the same rule of derivative, right? Same rule of derivative. Delta of one. Yeah. Same rule of derivative. So what you do here? You see. Now you have a G, F, Y, F inverse U, right? So if you want to do the derivative, but this is not U here, right? So you have to apply the same rule. So what you do, you put the same thing here. F inverse U here, right? Right? So you put this one here, so you have to put here. So F inverse U, right? Now you have U. So you this one cancel here, right? Remaining is same thing, right? You understand? Same rule, this is the same rule, okay? D, F, Y, F inverse U. It is the same thing, right? Right? What? So this is equals to negative, right? D, F, Y, F inverse U, and D, F inverse U, D, F inverse U by D. Okay. Hey, Amanda. Amanda, sorry. Hey, Autumn. Are you there?
Yes.
Okay. You understand these things, right?
Yeah, that makes sense.
Okay. So what is the sign for this one here? F inverse U by du. This is a decreasing function, right? Right? So it has a negative sign. Negative sign. Negative sign, right? Now it has a negative here. So negative will be positive here, right? So this will be, now if you take the derivative of this one, this will be the density function, Fu, F inverse U, right? Now, since this is a negative and this negative will be positive, so you will write the absolute value, D, F inverse U by D. Okay. Now that's what it is here. Okay. Yes. You understand? Now, let's go here. So this is a case two, that's what they are doing here. So this is the decreasing function here, and this is what they want to prove here. Okay. This F inverse, this F inverse here is equal to F inverse. Okay, short form. Now, let's do the one problem here. Okay. Now this problem is 6.7. 6.7 here. Now in this problem here, we have density function of y is 2y. It goes from 0 to 1 here, right? 2y. So now find the density function of u. U equals to negative 4y plus 3. Right? Now negative 4y plus 3. So it has a negative here, right? Right? So this is a decreasing function, right? So u equals to y equals to negative 4y plus 3 is decreasing. Is decreasing function. Right? It is decreasing function. So we want to apply this one here, right? We want to apply the find density function of u, right? U equals to minus 4y plus 3. That's what we want to find, right? So that is f u equals to what? Okay. Okay, the Friday quiz will be similar the problem like this one, okay? Friday quiz, so problem similar like this one. Now we have u equals to minus 4y plus 3 and minus 4y equals to u minus 3, right? U minus 3. And then 4y equals to now 3 minus u, right? 3 minus u. So then y equals to 3 minus u divided by 4. And this is now H inverse u function, right? That is H inverse u. Okay? That is H inverse u. Now you need a derivative here, right? You need a derivative here, this derivative. So we will take a derivative of this one. So d H inverse u du. So this is equals to take a derivative of this one here, this function. So e by du 3 minus u by 4. Right? So this is equals to what? D 3 over 4 by du. This is 0, right? Minus d u by du, right? Yes. So this is equals to 0 or 1 over 4 u by 4. Hmm? Yeah, 3 over u. Three over 4, not the u. 4. This is 4, right? 4, not the u. This is 4. U and 4 are kind of confusing here. 4. This is only u, right? So this is equals to negative 1 over 4, right? Negative 1 over 4. Now you see it is a decreasing, that's why we have the negative here, right? Right? Negative here. Now we want to apply this one here, you see? This one here, right? So we would like to apply f, u, and u. So this is equals to f, y, h inverse u, d, h inverse u by du, absolute value, right? Yes. So Fy equals to, so this is equals to Fy. Now F inverse U equals to this quantity here, right? So this is equals to 3 minus U over 4. And this quantity equals to this one here, right? Negative 1 over 4. Right? Right? Now Fy we have Fy y equals to 2y. This density function, right? Yeah. So here, now you have the input value. This is the input value, right? Right? Input, right? This is the input. So this is equals to 2y, right? So 3 minus u over 4, right? And negative 1 over 4, so this is equals to absolute value 4, right? So you cancel this one and this 2. So this is equals to 3 minus u over 8, right? Yes. Now what is the range here? You see, now you see, when y equals to 0, u equals to minus 4y plus 3. So this is equal to minus 4, 0 plus 3. So this is equals to 3 here, right? Right? So when y equals to 1, minus 4, 1 plus 3. So this is equals to negative 1, right? So it goes from negative 1 to 3 here, right? Yeah, negative 1 to 3. So here, so therefore, F u equals to 2 minus u over 8, and u lies between negative 1 to 3 and 0 elsewhere. Do you understand this problem? Yes.
Yes.
Okay. If you understand this problem, the quiz on Friday will be similar like this kind of problem. Okay. Friday, the quiz will be similar like this kind of problem. So you'll have the other portion of those kind of problem. Okay. Now, see this part here. Now we want to combine the increasing and the decreasing case, right? In the increasing and decreasing case, so both combining will give you this formula here, the single formula, right? Single, right? So this is the only one formula that we have to use for using this transformation technique, right? Transformation technique. You understand what I'm saying? Now you see what it is here. Now say here for increasing, case increasing, right? Case increasing, case increasing. Case increasing. So in case increasing, F, U, and U. So this is equals to Fy, F inverse U, G F inverse U by Du, right? That's what it is, right? You don't need a absolute value sign here, right? Because this is positive, right? This is positive. And in case decreasing, you have F U random variable U equals to Fy F inverse U D F inverse U by Du. but you need the absolute value here, right? In decreasing case, right? Yes, you need the absolute value. But this quantity is positive. This quantity here, because it is increasing, so derivative is positive, right? This is positive, right? And this is negative, but we need the absolute value here. So this is also positive, right? So combining these two formulas, we only need this one formula because this is positive, so we just need this one formula, okay? Yes, for both it will work because if you take the absolute value of the positive, it is the same thing, right? So that's what it is work. Okay, you get it? So this will be on the Friday quiz, and you will be doing the same assignment in San Diego. Okay, do the assignment. Okay, do the assignment. Now the steps here is the same steps that we are just following in our problem here. Find the inverse function, right? You want to find the inverse function. Take the derivative. Okay, then use this formula here. Okay, that's what the steps we are doing, right? Yes. Okay. Now let's do this one problem here. Okay. This is exercise 23 number from the book. Okay. So you have the density function here. Density function, it has a support 0 to 1 here, right? 0 to 1. Now you want the transformation u1 equals to 2y minus 1. So you want to find the density function for this u transform variable 1, right? Transform variable. By looking this transformation, is this transformation is increasing or decreasing? Huh? Increasing or decreasing? Second, increasing, right? So if we take the derivative, it is a positive here, right? It is increasing. So it is an increasing function. So you can apply the transformation technique. Okay, let me do the part A here. Okay, let me do the part A here. Now, now to do that one here, we have that u equals to 2y minus 1, right? U equals to 2y minus 1. Now, 2y equals to u plus 1, right? U plus 1. U plus 1. So y equals to u plus 1 over 2, right? So this is the H inverse u function, right? Now you take the derivative of this function d H inverse u over d, right? Take a derivative. This is equal to d u plus 1 over 2, right? Now what is the derivative here? So you can write this one as 1 over 2 because 1 over 2 is a constant, d u plus 1 by 2, right? Right? So what is the derivative now? Huh? 1 plus 0. So this is equals to 1 over 2, right? Yeah, 1 over 2. So you see this is the increasing here, right? Increasing function. Increasing function. Right? Increasing function. Now apply the formula now. F u u. So this is equals to f y H inverse U, right? Absolute value D H inverse U. Can you plug in the values now? Plug in the values now. F Y H inverse U is this quantity here, right? Yes. U plus 1 over 2. Now this is absolute value of 1 over 2. Right? So this is equals to, now see this one here. Now density function is given by this one here, right? Fy is this one here, right? 2, 1 minus y, right? Right? So we have Fy equals to 2, 1 minus y, right? So this is Fy, so this is the input here. This is input here, right? This is equals to 2, 1 minus, now in place of y, you have to u plus 1 over 2 times 1 over, right? Yes. Now you can cancel, this is product, right? So you can cancel this one and this one here, right? So this is equals to, now you take the 2 multiplied by 2, so 2 minus u minus 1 over 2, so this is equals to 1 minus u over 2, right? Now we have to look for the support for u. Look the support for u, right? Now you see here, whenever y equals to 0, then 2, 0 minus 1, right? 2y minus 1. So this is equals to u equals to -1, right? Right? So whenever 1, 2, 1 minus 1. So this is equals to +1, right? Yes. So it lies between -1 and +1, right? So therefore u equals to 1 minus u over 2, and u lies between -1 and +1, 0 elsewhere. Right? Did you get it? Hey Autumn, did you understand?
Yes, I understand that part.
Okay. Okay, let's do the one last problem, okay? One last one. Let's do the, okay, let me do here, this one here, C, okay? Part C, yes. Now you have u3 equals to y square, right? Now y equals to root u, right? Root u, right? Root. But it could be positive and negative, but we have y only positive, right? Y only positive here. Yes, y takes only the positive value. So it means that y equals to root y, root u only. Okay. Y takes, because y lies between 0 and 1. Right? And this is now H inverse u. Okay, now take a derivative. Okay, take a derivative. G S inverse du. Okay, so G S inverse is square root of u du, right? You see, now this is equal to what? Square root of u, G u exponent 1 over 2, right? For the square root. Okay, now you just apply the differentiation rule. So this is equal to 1 over 2 u 1 over 2 minus 1, right? So this is equals to 1 over 2 u negative 1 over 2, right? This is equals to 1 over 2 u 1 over 2, right? Yeah. So this is equals to 1 over 2 square root of u. That is the derivative, right? Now apply the formula here. Now f u u equals to f y s inverse u and d s inverse. Okay. So this is equals to f y s inverse u equals to this root u here, right? And d s inverse u equals to now 1 over 2 square root, right? So this is equals to now plug in the value for this one here, hy. So hy is this one here, right? hy is this one here, 2 1 minus y, right? Right? So you plug in the values here. So this is equals to 2 1 minus root, right? Divided by 1 over 2. So this and this cancel here. So this is equals to 1 minus root u over, right? Now what you do? Now you have to find the support for u, right? You want to find the support for u. Now support for u. So y equals to 0 and u equals to y square, right? So 0 square equals to 0, right? Right? And 1 square equals to 1, right? Right? So it's equal to 0 to 1, right? Yes, 0 to 1, yes. So you have, therefore, f u equals to 1 minus square root of u over square root of u, and u lies between 0 and 1. And this is the answer. Okay, or plus 0. You understand? Hey, Autumn.
Yes.
Okay, so this will be there will be a similar problem in the quiz. Okay, problem will be similar in the quiz Friday. Maybe one problem or two problem. Okay, and do this assignment. Assignment will be also the similar assignment on the SynGate. So it will help you to understand better because you will be do some more problem. Okay. Okay. Yeah. So I'm going
Okay.
to stop now, and quiz in person. Okay, Autumn, come to the class.